I'm Bob Vandette. I work in the product group at Sun Microsystems, and I should probably do the same disclosure that Microsoft did here, that the opinion stated here are mine, and you have to guess which ones are mine versus Sun Microsystems. Okay. When I was asked to put a presentation together, rather than come up here and tell you, give you the virtues of Java and how wonderful we are and what our plans are going forward, I thought that I'd go through and give you a historical perspective of the products that I've worked on. And all of them have some virtual machine technology involvement, and go through some of the challenges that I had to face in the past. And you'd be surprised that a lot of those challenges are still challenges today in our current technology. So I'll go through some of those things. So here's kind of the uses of virtual machine technology that I've been involved with. Trying to bridge old and new architectures. Does anyone remember CP/M? When the IBM PC first came out, there were no applications. Can you believe that? It's hard to believe today, but we worked on a board that actually ran CP/M applications inside of an IBM PC to help bridge and bring those DBase 3s and WordStar applications to that platform. Then as the IBM PC became more and more popular and there were more applications there, the Unix workstation folks were demanding, I want those applications, and I worked on technologies to bring those applications to those platforms. I cannot install this hardware. It's like, you don't need to.
Yeah, just press return.
Press return.
That's it.
And finally, with the experiences of doing virtual machine technology and the fact that we had to find the workstation folks, that Unix world had to find solutions to keep from having to pay the Lotus 123s $10 million to port their applications to this platform. I think that was one of the driving forces to force folks like IBM to go after the ANDF technology and finally to come up with Java. So here's kind of a timeline of things that I've worked on in the early 80s. Worked on hardware coprocessors to plug into Unix workstations. Then as the Virtual86 technology, Intel allowing virtualization of these DOS-based applications, I developed a piece of software called VPIX, which would actually allow you to run virtual PCs inside of a Unix environment. Then as the RISC processors started to come out, it was possible then to emulate not only just the environment of a PC application, but also the actual Intel processor itself. And that still didn't have the actual best performance solution for running Windows applications, as we ended up with more and more complex environments, protected mode, and high graphic throughput. That kind of forced me to try to take a different slant of things, and I'll get into the lobby technology. And finally, in the late 90s, we finally had Java virtual machines where we could actually run applications on multiple platforms without actually having to reinvent and port these virtual machines to different platforms. So I'd like to go through a little bit of the pros and cons of each of these technologies that I've worked on. The hardware coprocessor, you can say, well, this isn't a virtual machine. You've got a PC inside of this whole board, so where's the virtualization? Well, actually, we had developed many different forms of this technology, and we had to design the software such that we had different layers of virtualization. The cheapest coprocessor we ever developed was for a company called Hewlett-Packard, where they had a simple Intel processor, the card plugged into the memory bus, had some I/O trapping logic, so everything except the actual Intel processor was virtualized. This is the Sun PC board, where there actually is a VGA on board, and memory, and processor. So there's very little virtualization. Perhaps the file system and windowing system and drivers to try to do some integration on the desktop. The benefit of these is you have great compatibility. It was a pretty large time to market. By the time you get this design out, the processor that you actually put into this board was outdated, and you weren't really competitive with the application execution performance that was available from a cheap PC at the time. So it wasn't the best solution, but it was the only solution available way back then.
I just want to point out, if you look at the bottom of your charts,
They say something a little embarrassing.
Okay.
But you've authorized IBM to edit that out.
Yeah.
We've all been offered jobs. What do you
I'll modify the bastard. I'm sorry.
Yeah.
Just grab one of our Java licensee slide templates to do this, but I can fix that. So with the introduction of Virtual 86 mode, this is actually the best price, performance, integration, resource usage solution that I ever worked on. Because you're sharing the processor, there's very little overhead in doing any kind of trapping. You're sharing the memory and subsystem. There was almost no performance loss whatsoever when you're running a DOS virtualized application. Perhaps this was, because of the fact that, Microsoft went to Intel and said, all right, let's design this thing. We have this legacy set of applications that we want to run. And they really worked at it from a software, hardware perspective to do the right hardware with minimal overhead. And they did such a great job that this translated even in the Unix world when we ported this technology, did modifications to the Unix kernel to provide this virtual 86 environment underneath. Applications, each process, a DOS application was a Unix process. So you didn't have this special world where all of these threads are running within one single process. It was actually the best performing solution today. Let's see. One of the problems of this is the fact that Intel didn't actually virtualize the entire processor. They only virtualized the real mode aspect of it. I suspect that they're working on these things today, right? The VMware folks.
I can't say what VT is, but I think the mistake they made is they didn't virtualize the processor. What they did was added a mode for running 16-bit things, and I worry they're going to make the same mistake again, which is basically they'll add a virtual Pentium mode or something, which then means you have all the same problems.
Yeah, if they'd only gone one extra step, then we could have all, had Windows and Unix and whatever running on the same exact box with no noticeable degradation. But unfortunately, the effect of trapping your LDTs and all the protected mode state and changing that state was very expensive. And company Locus Merge 386 actually attempted this, and it did work, but there was a performance overhead that was very limiting. So as the process got faster, we decided to take the leap, and other companies, Insignia Solutions, did the same thing with their soft PC and soft Windows product to actually do a complete virtualization of the PC, including the Intel ISA. And we use similar techniques we use today with Java. We started out with our interpreter, and then finally it came to the realization that we needed a JIT, and we had 3 or 4 different versions of the JIT, each increasing performance, and it had a lot of the same problems and limitations that we have today. In terms of performance of this architecture, performance on all but the fastest RISC was never competitive with the PC that was available for $2,000 or $3,000 on the street. So we were always chasing that performance curve. Well, it was kind of at the time a check-off item. You had to run DOS applications on Unix workstations, so it was forgiven, and there was actually a market for this technology. And both companies sold considerable amounts of these. We actually licensed it to every OEM Unix manufacturer that was available at the time. So it was a popular item, but it was far from, this is the world's best solution. I have Unix applications and DOS applications all running at the same speed that you could buy off the shelf, unfortunately. So given that the world was going graphical and Microsoft was finally getting away from the DOS and touching the bits and providing APIs to do graphical operations and menuing and windowing systems, I decided to take a real risky jump and go, well, let's just cut at that layer. We've talked during this conference all about what's the right layer. So let's get from the low level and move our way up so that when a Windows application creates a window, let's just get out of that virtual machine box that's running virtualized and get right into the native code and let the native operating system actually create a window. and let it, do blitz instead of, moving the bits inside of a virtualized mode. And it actually, was extremely popular, and every workstation manufacturer licensed this. We worked with IBM to increase the performance of the underlying JITs, and USL, SEO, every one of them licensed this. It was, we had demonstration software of this WinTAC that would run 10 times faster than the soft PC equivalent virtualized environment. So we had this great performing solution. The problem is when you have